Okay, hi there, part two. We're just continuing where we left off. To start off, let's look, maybe before we go into chops, I want to talk about how you can find out some more info about all of these operators. Um, as you open up the opcreate dialog here, you might notice if I do level, at the very bottom there, it gives you a little description. Adjust image contrast, brightness, gamma, black level, color range, quantization, opacity, and more. Okay, so for level, that makes enough sense. For something, for some of these though, I feel like that if you don't know what the operator does at all, a lot of times that description I feel really doesn't help. So for example, slope, it's a little more complicated. This says generates pixels that represent the difference between its value and its neighboring pixels values. So I don't necessarily know what that means. And especially as a beginner, I feel like this is not really the best way to just kind of stroll through these operators and just kind of pick ones at random. So a better way to learn about the operators would be, let's say if you select one, hit P to see the parameters over here. And then up here in the parameter window, we have a couple question marks. This says help, this says Python help, and then this says info. The info we have seen already. It says this type of stuff right here. So also I can get it if I just middle mouse click right there. It gives me some info about the video signal that is inside that. But more importantly right now, let's just hit this question mark help. And what that does is it automatically opens up the Touch Designer wiki, switch top. So it gives you a description. It gives you descriptions for all of the parameters. So this helps a lot. Just kind of give you a sense of what all of those things do. So this is much more of a help. The Python stuff we don't have to worry about right now. What it does is it gives you certain methods that you can use if you're writing Python scripts to kind of interact and do stuff with that particular operator. So here's the kind of magic words that you can use. So we don't care about that right now. Another great spot for learning is if you go up to the top menu up here in help, operator snippets. And this is kind of like if you learned Max MSP at all. Famously, that's really great for just having like a help patch for all of the different objects in Max. So it's kind of like that. So with the snippets, it doesn't have snippets for all of the operators, but for many of them it does. So I had switch selected, so it automatically took me to switch. It's got 3 different snippets examples for how you might use this little description here. So this is great. You can kind of look at this and just kind of see like what kind of network, what kind of operators does it need, like what can it do. So this would be helpful if you're just starting. So layout is really cool. So you can even just kind of be in the snippets and just kind of click around and see what shows up to get a sense of what the operators do. So that helps. Okay, great. So now let's talk about chops. So we looked at all the tops. Chops stands for channel operator. This is basically modulation data, channels of data, contours of data, which can be used to modify or modulate some other parameter somewhere. And also because audio is essentially just a stream of data, all of the audio functionality is right here. So bringing in audio files, adding audio filters, stuff like that. We're not concerned about that right now. Okay, cool. So what we're going to do is, like for example, let me just go into the ramp right here. So I had ramp, hit P to see parameters. So some of these parameters here, let's say phase. Let's see what happens. So I can see if I play with the phase, it's essentially moving this around like so. So, okay, that's great if I can, do that manually. But what if I could have some sort of other operator that's like automatically changing this value? That would be pretty cool. So that's what we're going to bring in chops for. To start, let's look at a couple of the most useful chops, I think. This first one, LFO, stands for low frequency oscillator. And we can see it's kind of just moving around there. And to better see the contour of this data, I like to add a trail chop. And so it's just, so the LFO is just showing us one sample at a time, but the trail is showing us window length 4 seconds worth. So it's kind of showing us 4 seconds of data coming from the LFO. So it just kind of helps kind of see it. So we can see more clearly now. So this is a sine wave. It's going up. Maximum is 1. The minimum is -1. If I hit parameters for the LFO here, we see different things. So frequency, if I make it slower, looks like that, or faster. Cool. Offset amplitude, so if I did like a little bit higher, let's just type in 1 there to see what happens. Okay, so now the kind of middle point is 1, amplitude is still 1, so that means it's going up to 2 and down to 0. What if I did amplitude like 5? Let's do offset 0 again. So now we can see, so offset 0, so that's the kind of middle point. Amplitude is 5, which means it's going up to 5, down to -5. So offset amplitude is basically going to allow you to shape the range and position of that data. Phase is kind of like, if I pause here, phase is going to take us, if you remember back in geometry class, there's this sort of the different phases of a sine wave, right? Kind of this point here, the maximum, back to 0, the minimum, back to 0. Those are kind of split the phase into different quadrants. So you're basically kind of moving that wave around. So let's just, whatever, keep that right there. That's fine. Okay, so LFO has different types. So that's a sine wave. Gaussian. Just go back to amplitude 1 to keep it simple. Okay, so slightly different shape. You can see that just the shape of that is a little different. It's gone from 0 to 1. So the Gaussian wave behaves differently than a sine wave. And triangle. Right, so no smooth sine wave curve. It's just a pure linear triangle wave. So this one goes -1 to +1. A ramp. This is also called a sawtooth wave, especially if you're working in more audio applications. So it ramps up and then jumps straight back down to 0. For this, phase actually matters a little bit more. If I did, let's say, like phase 0.1, let's see what happens. Oh, actually, it's the same shape. Sometimes you get a kind of bias. You kind of make the sawtooth lean. So I forgot it doesn't actually do that in the LFO. Okay, ramp square. This is more of like just an on and off. Also going from 1 to -1. And pulse. This is just 0 to 1. It's just a pulse of 1 sample long, up to 1 and back to 0. Okay, great. So let's go back to sine. I'll get rid of trail for now. I want to use this data to modify my phase parameter right here. So super easy. I can, just a couple steps I need to do. First, hit this little plus sign. So second, make sure the parameter you want to modify is visible over here in the parameter window. So once we hit this viewer active, I can now click on the channel name, drag it over to the parameter. It made this little arrow thingy. And when I'm over the number box, it highlights, release, and I'm doing a chop reference. And there it is. And it turns blue because this value is now identical to the value that's in my LFO. So, okay. So now I don't really like this hard edge right here. Actually, let me pause that for a second. I can change that in the ramp, extend. Instead of repeat, I can do mirror. I think I like that better. There's different kind of things. Hold. Just see what hold does. It kind of holds whatever that last color is. Black. Don't want that. 0 just makes a totally 0 alpha. So repeat is what it was before. Mirror just kind of makes it without that hard edge. Okay, I like that. But also, I don't know, this, maybe I want it to kind of go through the phase a little bit more. Let's play around with this. Let's do, so the viewer is active here. I selected this. If I hit P, it's not going to, the parameters don't open up. Also, I have to be careful because if this was selected down here, if I hit P, then you can kind of see what happens. I'm like, actually, you can change the names of all these things, which is fine, but I don't want to do that right now. So I need to click that again, hit P. Now the parameters open up, and let's make that a lot slower. Actually, let's do 0.1 maybe. 0.02, something just like really slow. Okay, I like that. Just kind of like a subtle shift. Okay, because then that's going in here and it's changing this color. There we go. It's like a little sunset. Okay, cool. And let's see, what else can we do? Let's look at this switch. We played around with this index right here. I have blend on. So this value right here, because I've got how many inputs? So I got 0, 1, 2, 3, 4. So what if I did another LFO? And let's do like a ramp. I don't know, 0.1. And I want this to go amplitude 4. What if I did that? Then it goes from 0 up to 4 and then back to 0. You know, actually, I think I'm going to go ahead and do this, but then I think I'm going to want to make the amplitude 5. Okay, index 0. Okay, again, viewer active, parameters visible over here, drag, chop reference. And then I'll go ahead and just bring that back. Okay, so let's see. Because it's going up to, because it kind of hits 4 and then immediately jumps back to 0. So we're really not, because when switch, the index is 4, that's when we see this thing. But you can see it's only 4 for like a little split second. And also I realized I don't really like that hard jump. Because that's the nature of this ramp. It jumps from the maximum back down to the minimum. I think I might instead like a triangle. So now we have to think about, let me just pause this for a second. So for switch, this value needs to be between 0 and 4. But right now, and we can see this with the trail, my triangle wave is going from -4 up to +4, back down. So all of that time at -4, it's this is just kind of like locked at 0. You can see it goes up to +4 and then it goes all the way back down. So that's not quite the way I wanted. Let's do, what if I did something like this? Let's do offset 2. No, let's do like 3. So, and this way now it's kind of like hanging out on the minimum and maximum a little bit because it's going up like kind of beyond 4 a little bit and then it goes back down, which is fine. chilling for a minute, going through it, chilling for a little second, and then back down. Okay, I like that. So it's really a matter of, you're shaping your data like the data is like clay. You're shaping it into the right contour, the right form for whatever the destination parameter is that you want to map it to. So this idea of like mapping one thing to another thing, it's a constant and a very important concept. Okay, so those are LFOs. Let's look at something else. Let's look at noise. Cool. So noise is a bit of randomness. We've got different types of noise: sparse, Hermite, harmonic summation, Brownian, totally random, and alligator. So you can see sparse, ostensibly, it goes from +1 down to -1, but just depending on the nature of the random numbers, it might not actually get to those limits. For seed, it just completely changes it, like so. Okay, whatever. It doesn't. It's totally arbitrary. Let's do a seed of 55. I don't care. Periods, low periods, kind of makes it more tiny, more resolute, and higher period stretches out like that. I'll just keep it at 1. That's fine. Same harmonics. This is similar to the noise top, right? It's got similar parameters. If you want like little more spiky little edges, it's fine. Roughness up and down. So all these things, it's like clay. You're shaping that data. Exponent that becomes these kind of like square wave thingies, or super flat. So you're just kind of tweaking that math here. So amplitude, we'll just keep amplitude and offset the way it is right now. Okay, so I'm gonna actually we can look at these other things too. So transform, this will be really handy later, but I'm gonna do the middle mouse click value ladder. I'm holding middle mouse, and now I'm gonna drag. Actually, let's do this a little more. Kind of see, I'm translating that data along the X, along the Y. What does that do? So that kind of does that. Along the Z, kind of morphs it. So that could be a kind of a cool thing if you want kind of slowly morphing random noise values. Then you can animate this translate stuff. Rotate. Yeah, that doesn't do anything. That does something. How about Z? Yeah, Z does something. Okay, cool. And then scale, let's see. That's kind of like changing the period in a sense. And pivot, I've really almost never really messed with pivot. I guess if I do like a rotate, then that matters. I've hardly ever played with the pivot there, but okay, cool. Constraints. So this could also be kind of cool sometimes if you need the start point to match the end point. We can add constraints. Actually, I'll do that in a minute because I'm about to animate the rotation for this little square here, and then we'll see what happens. So channel. So by default, it's chan 1. I mean, I could name it whatever I want. Rotate. Beautiful. So now it's called rotate. By default, it starts at 0 to 10 seconds, which gives us 600 samples. This little I here means samples. It's got 10 seconds worth of noise data, and that's because our frame rate is always, if you look down here in the lower left corner, frames per second is 60 frames per second, and you can see up here also I'm getting 60 frames a second. Most like in any network, if you start to get a little more complicated, you'll see this kind of dip down because the computation is working a little bit harder. So what, I mean, I could kind of change this too. If I samples, I can see that right there. So 0 to 599 is equals 600 samples, whatever. Like if I didn't want this much data, I could do something like this. So just 0 to 1. Now if I middle click, I can see I've only got 60 samples of data. And also to see these samples, I could do something like viewer active, right click, and dot per sample, hit that. And I could kind of zoom around in this. If I hold down the middle mouse button, well, let's see, left mouse button, I can kind of just click, drag it around. Right mouse button, not doing anything. Middle mouse button, if I click and now kind of drag up and down, this is doing that. Left and right. So I can kind of just get so each one of these little dots is a different sample from 0 to 59. So we've got that many samples there. Okay. I don't really care about that right now, but horizontal adapt, vertical adapt. Let's just get rid of that. Okay. And let's get back to like 600 samples. Okay, cool. So that's just kind of looking at the data a little bit more. All right, so what I want to animate. Let's look at this transform here. Let's look at the rotate, little shimmy shimmy. Cool. So let's just do the same thing. I don't have to put that close to that. It could be like anywhere, but I just find it helpful, if it's close to it. Okay, viewer active. Parameter is exposed right there. Great. Drag the channel over to that. Chop reference. Okay, so it's working. And also for all these, whenever you do chop reference, you see this little arrow that's now connecting it. It's the same thing down here also. We've got this little arrow that's kind of animating right there. So that lets you know that there's some sort of a reference. So if this was like, for whatever reason, if I had this thing living way over here, it still has this little arrow, so it tells you that it's connecting to something. But I see a problem. It's like such a tiny little animation. That's because the amplitude of my noise is only 1, so it's only going up to maybe 0.5 and negative 0.8 or something maybe. But rotation is dealing with degrees, so 0 to 360 degrees. So I need to really boost this up. Let's do like, 30. That looks better. Okay. Oh, do you see that little jump? Let's watch it again. It's going to happen right about now. That's because the value of the rotation, when it hits this, it kind of jumps back to this value. Because right now we're kind of animating through this contour, even though this isn't changing. The value for rotation is running through this value. Okay, so I think I want the last sample to be equal to the first sample, so I don't get that weird jump. To do that, constraints. Let's do this. Constraints, start in values, and I'll just make starting and ending both at 0, and we can see that right now. Now they're both 0, and I'm not going to have that kind of hard jump anymore. Cool, love it. Okay, cool. Let's do maybe one more top thing that I didn't show before. I didn't really look at the text situation. Let me just drag this over here. I'm going to get text, just put that wherever. And so, I don't know. Normally I would ask in class, like, okay, what's your favorite animal? I'm more of a dog person. Let's do puppy. Puppies. Everyone loves puppies. Puppy. Okay. And do font. We can do whatever your system fonts are. Cool. Okay. And let's make it bigger. I can change the color, all that stuff, whatever. Okay, so let's do a composite and just see what happens there. Composite. Okay, drag this in. Okay. Oh, look, same problem as before. Text by default is 256. My system is 1280. Fixed layer is input 2, which is the text coming in, so therefore this is 256. So again, a couple ways I could change this. I could just do it like that. So now it's grabbing the resolution from here. But this looks awful. This edge is super blurry because it's taking, so this is still only 256. And the pre-fit overlay, what it's doing is it's actually filling this, it's like stretching it to equal the size of this. So not only is it distorting it, it's like making it bigger. It's just kind of looking awful. I mean, I could just do like native resolution. Oops, like that. So right there, native resolution. So this remains 256 and doesn't get distorted, but then it's kind of like tiny. So I just got this idea. I wanna just make this word puppy like as big as the whole screen. So I'm gonna go into common. I'm gonna go ahead and change that so it's bigger. And let's do this fonts. Let's just like totally make this as big as possible. Okay, kind of love it. I'm like, yeah, that's cool. That's really cool. Okay, so then, okay, so I'm just like thinking of all these other things now. I'm gonna do another edge. Oops, not displace. Not quite yet. I'm gonna do another edge, which gives me that. Let's do an over. So that goes in the bottom. Actually, you know what? Oops. I forgot. I could just do it easier. I could just drag that directly in. Ooh, no, actually I don't want to do it because I don't want to get an edge for the inside of things. Yeah, whoops. Never mind. So I do need an over. That one and that one. Okay. That's cool. All right. Okay. Looks pretty good. Now, I don't know. Let's just do like a... Let's do just like a normal background. Just a plain old background. Insert operator. I can do a constant. What I can do, output. It's output tag, comp with input. Check. Operation over, swap order. Yes. So now it's basically putting the input over the constant stuff. And let's just do like kind of a grayish color. Okay, I kind of love that. That looks great. And maybe that's good for today. Okay, enjoy.